Okay, so to do this derivative, you've got fraction minus fraction. So f prime of x equals 4, the 4's will cancel, x cubed minus 3, the 3's will cancel, x squared. All right, so cleaning it up, f prime of x equals x over 3 minus x squared. So that's your derivative. Now, if you're going to set this equal to 0 to find critical values, right, so we're going to say, what do they have in common? They have x squared in common, and then I'm going to say x minus 1 equals 0. So what are my two critical values? If you set your factor equal to 0, x squared equals 0, so x will be 0. X actually be plus and minus 0, but 0 is fine. And x equals 1. So let's go on the next page and we'll figure out what we're going to do with those points. Okay, let's take the second derivative too to give me information about the inflection point. So looking at your f prime of x, I'm going to get 3x squared minus 2x. So setting that equal to 0 is going to give me the inflection points. So let's see what we're going to get. We can factor out an x again, right? Yeah. So I have 3x minus 2. So it looks like I have two inflection points. So I'm talking about just the x values of inflection points. I have x equals 0, and then I have x equals positive 2/3. So let me erase that. Okay, x equals positive 2/3. All right, so these are places where the concavity changes of my function. So let me just think about my function for a second. So since I really don't need this little space up here, let me just get rid of this so I have a place to do some graphing. So I'm not sure, point of reflection and sketch graph. Okay, I'm not sure what you're required to do in terms of having a statement with these critical values. So we're going to kind of go through that a little bit. What I know right now, given my function, is the following. I know that it goes through 0 because if I set my function equal to 0, I get 0. So that's going to be my y-intercept. Okay, then the other thing I know is that at 0, I have an inflection point. And at 1, I have either a max or a min, okay? So let's test those. So if I'm going to do a critical value test, I'm doing a sign chart. So I have x is 1 and x is 0 and x is 1. So the way I do my test, and I think I need my derivative again, so let me go back and grab the derivative, which was x cubed minus x squared. So let me go back again. So I know that f prime of x equals x cubed minus x squared. So if you test to the left of 0, so you put a negative in x cubed, so let's test negative 1. If I put a negative into x cubed, I get negative 1. So I would get negative 1 minus, if I put a negative 1 in x squared, I still get 1. So negative 1 minus 1 is going to be a negative number. So that means right here, to the left of 0, the slope is negative. Now pick, say like 1/2 in between 0 and 1. So if I cube 1/2, I get 1/8, and 1/8 minus 1/2, that's going to also be negative, which is what I kind of knew because I know that 0 is an inflection point and not a max or a min. So now let's go to the other side of 1. What if I put in 2? If I put in 2, x cubed is 8 minus 2 squared is 4, so that's going to be positive. So what I have now is an inflection point at 0, and at 1, what does it look like? Well, if my slope was negative and then a positive, I must have a min there. So here is my x value of my inflection point, and here is my x value of my min. So you want to now get your value for your y so that you know where that min is going to be. So, and in terms of concavity, what's happening is the concavity is changing on either side of 0 and 2/3 because those were our reflection points. So we're going to talk about that in just a sec. Okay, so you have a lot of action going on right around the origin. So let's go to the next page and let's see if we can graph this. So I think I can get some graph paper. Do I like that? Sure. Okay, so let's say that this is the origin right here. This is what's happening. So your function's coming down like this, and it's going to have an inflection point right at the origin. Okay, so slope has been negative. I have an inflection point at the origin, so it has to get flat, and then it's going to turn slightly down. Okay, and right at right at x is 1, I'm going to have a minimum. And then it's going to go back up. So here's my min. And that point that I have a min at is 1, -1/12. And I got that by saying evaluate your function at 1, and you should be getting -1/12. So this is your critical number, 1. This is the y value, so that means this whole thing is called a critical point. Okay, that's your critical point. Then here at 0, 0, you have a slope of 0 because of the inflection point, but this 0, 0 is your inflection point. Okay, let's speak about the concavity. What happens to the concavity is if you analyze your second derivative, okay, so I'm going to analyze my second derivative. So this is f prime prime of x. Here's my two inflection point x values. So right at 0, I'm seeing that my function is changing, okay? So to the left of 0, I am concave up. At 0, it's changing. Between 0 and 2/3, I am concave down. And then to the right of 2/3, I am concave up. So in terms of colors on the graph, we'll make concave up blue, and we'll make concave down a different color. Okay, maybe we'll keep that red. So where is concave up? Concave up is all here. Okay, then you have a change. Then you have, let me see. Yeah, then you have concave down in that little window. And then right here at 2/3, okay, so this is going to be 2/3. My function, again, turns concave up. All right, so I have two little tests going. This is a test of the second derivative in terms of concavity. All right, and that's the change that's happening. All right, so in terms of sketching it, I can sketch it. Everything is very tight around the origin. If you wanted to see it on your graph, you would have to zoom in very, very tight. Okay, let's tackle question number 2. Okay, so here I wrote out your problem 2A. So this is kind of interesting. So first off, remember that radicals are not your friend in calculus. So you've got to first write your function like this, to the 1/2 power. So take your derivative. The way I got the 2x is through the chain rule. Okay, so I said bring the 1/2 down, don't touch anything inside the parens, raise it to the negative 1/2 power because 1/2 minus 1 is negative 1/2. take the derivative of the inside, which is 2x. Okay, so I find it helpful at this point if you're going to try to evaluate critical numbers. And critical numbers is the same as my critical values. It's the x value that you get when you set the first derivative equal to 0. Okay, so what happens is my 2's cancel, and I'm left with x over radical x squared minus 9 equals 0. Okay, the only way that can equal 0 is if the numerator equals 0. That equals 0 at x equals 0. Okay, but this is very, very critical for your class. You cannot say that x is a critical number because that x is not, absolutely not, in the domain of your function. Because look what happens. If you plug a 0 into your function, you get radical negative 9, which is imaginary. So your domain of your function does not include 0, so therefore you have to say there are no critical numbers. Okay, that is very, very key. Okay, let's go on to 2b. Okay, so I've written out some things. Just a little quick aside. The domain of your previous function was this. Okay, you have to avoid any numbers between -3 and +3. Okay, so that's why we had to eliminate 0. Now it's going to be the same here because you cannot have your underneath your radical go to 0. So this is what I have so far. I rewrote my function so I can take a derivative. So I'm using the 1/2 power again. So now I'm taking my derivative. So this is left, and then I'm just going to color this for you. And this whole thing was d right. So make sure you understand that this is the derivative of x squared minus 9. So it's the same as I had before, basically, with the exception of now I'm multiplying by x. So 1/2 x squared minus 9 to the negative 1/2, and then I did the chain rule, and that gave me the 2x. Okay, the 2's cancel. I still have an x in front, and I have this other x. So this first term will become this. Now we have to do the other half of that derivative. So I did lefty right plus right, and then the derivative of x is just 1. So this is what I'm getting. So what I am thinking at this point, I want to look at this as one term. So I'm going to multiply the second term by radical x squared minus 9 over radical x squared minus 9, so I can have the same denominators. Okay, so my numerator becomes x squared minus 9. So let's go to the next page. We'll take this with us, and we'll go to the next page and see what we're getting there, because we're still looking for critical values. All right. No, I don't want that. Okay, go back, and let's try to do this. Okay, so I want to copy that, paste it here. All right, so that's good. All right, so let's see what I'm getting now. So I am looking at writing my derivative, and I get x squared from that first term, plus when I multiply, when I multiply these guys together, I get x squared minus 9. So therefore my derivative equals x squared plus x squared, so 2x squared minus 9. Okay, I'm going to set that equal to 0, and I'm going to get 2x squared equals 9. So x squared equals 9 over 2. Therefore, x equals plus and minus 9, radical 9, which is 3, over root 2. Okay, so what is that? 3 over root 2. Is that a number that is, so I'm going to just put this in my calculator. So 3 times second square root of 2. So that's going to equal 4.24, and I'm great. So I can use both of these critical numbers. So plus 3 over radical 2. So here are my two critical numbers or critical values. Plus 3 root 2 minus 3 root 2. They both work because they're in the domain of the function. Remember, going back, looking at the domain, I said this is what it has to be. Here is where your 3 root 2 is. It's about 4.24, and then negative 4.24. So both values work. So in this second problem, you have two critical values, two critical numbers. That's this. In the first problem, you had none because your answer was not in the domain. Okay, so that takes care of question 2. So I'm going to go through and differentiate all of the problems in 3. Okay, so I've written out the derivative of your first problem A. So it's going to be, so let me just write this through. So it's left, okay, just write down what you have on the left. Okay, D right. Okay, the derivative of the terms on the right. The derivative of sine 2x, so sine 2x, so let's just take that. So this is sine 2x. The derivative of sine is cosine. Never change your angle. Then you've got to take the derivative of the angle, which is 2. So this 2 I brought in front. So that's how I have 2 cosine 2x. Okay, so then I'm going to say plus, okay, the derivative of cosecant x is negative cosecant x times cotan x. So I had a plus of a minus just to show this to you, but never have that, so it's going to be minus. So make that a minus. All right, so this is left, D right, and then plus, so let me get rid of some of this in the bottom in case I have to do anything else. So plus, just write down what you have for the second term, which is the addition of those trig terms, and then D right. Here is your D right. Bring down the negative 2 in front, and this is a product, so I'm not going to change. Well, yeah, I'm going to change in just a second. So negative 2 comes down in front. X squared plus 1, go one more negative, that makes it negative 3, times, don't forget the chain rule, the derivative of the inside, which is 2x. So what am I getting for my answer? Well, this negative right here, so the negative in front here, is going to flip that. Okay? So let's see what I have. So I'm going to just write it as neatly as I can. So my first term, I'm going to have 2 cosine 2x minus cosecant x cotan x all over x squared plus 1, and that is now squared because I have it in the bottom. Okay, and then it's going to be minus, because of that minus in front of the second term, and I'm going to use parentheses, sine 2x plus cosecant x. Okay, so we're going to do it this way. I'm going to put this in the bottom, x squared plus 1 cubed. Now I'm going to move my equal sign a little bit because this 2x and this 2 make a 4x, which I'm going to put right there. So that's my final answer for problem A. Kind of a mess, but there you have it. Okay, so it looks like you're going to need to know all 6 trig functions and their derivatives. So I just Googled that because I only really memorized 3 of them, and then I always work with those 3. So you can Google that information and get your trig functions. In fact, why don't I do that in the next page for you? I'll just write them down. Okay, so here are all 6 derivatives. Now remember, you have to take the chain rule if your angle is not just plain old x. So you only have 3 that have negatives in them. So the derivative of cosine is negative sine. The derivative of cosecant is negative cosecant x cotan x. and the derivative of cotan x is negative cosecant squared x. So I hope you can read that. But those are your 6 trig derivatives that you're going to be working with. Okay, so here's another derivative. So f prime of x equals, okay, the derivative of a natural log is going to be 1 over x minus 1 over x plus 1, and then times the derivative of x minus 1 over x plus 1. So that derivative is going to be log x plus 1 d high times 1 minus, my stylus is giving me a hard time, minus high, so x minus 1 times 1 over x plus 1 squared. So let's see if we can clean this up a little bit. Okay, first off, your first term, instead of having it be a double-decker, what you can do is write that as x plus 1 over x minus 1. Do that division and you'll get that as your answer. Okay, so this is being multiplied by, okay, x plus 1, and then I'm going to subtract that. So let me change my color so I can see what I'm doing here. So this is going to be x plus 1 minus x plus another 1. So it looks like that becomes only a 2 in the numerator. So I'm going to change that back to my green. So this is times 2 is in my numerator, and then I have x plus 1 squared in my denominator. Okay, so what's going to happen now is you can really present your answer as 2 over x minus 1 times x plus 1, which is just 2 over x squared minus 1. All right, so how come I did that? Well, what I did was I canceled this power with this numerator. That became a 1. I then multiplied straight across. I have denominator times denominator. Either of these two answers is fine. So that's question B. So let's go on to question C. Okay, so what you have here is a product, and your first term is an E term, and your second term is a trig term. So I'm going to say that, let me see, okay, so you didn't have f of x, but you need to have f prime of x equals, so left, exactly what you see, d right. Okay, d right is going to be cosine of x cubed plus 4 times 3x squared. Okay, that's our first term. Plus right, so just sine x cubed plus 4. D left, write what you see, x cubed plus x, and then take the derivative of the numerator. So times 3x squared plus 1, put that in parentheses. Okay, so do I need to do anything to clean this up? Let me just write it again, and I'll bring my terms together, see if that helps you. Okay, I would bring that 3x squared into the front, and then I have e to the x cubed plus x, and then I have cosine of x cubed plus 4. Okay, that's my first set of derivatives by doing lefty right. And then plus, I'm going to write this in the second line. I would again bring the 3x squared plus 1. Remember the parentheses, that's critical. And then I probably would put the ex cubed plus x next, and then I would have the sine x cubed plus 4. So that's my final answer for C. So let's go on to D. Okay, it looks like this is going to be a crazy problem. So let's take this derivative. So the derivative of natural log of anything is going to be 1 over whatever is behind it times the derivative of what's behind it. So the derivative of natural log 2x is 1 over 2x times x. So I think that's correct. Let me just think about this. So 1 over natural log of that times the derivative of what's behind it, and that derivative is, that derivative is not that. So let me go back for a sec. Okay, so let me think about this again. So 1 over natural log of 2x times the derivative of natural log of 2x. Okay, the derivative of natural log of 2x, yeah, that is right. Let me think about this. Yep, I'm right. Okay, so the derivative of natural log of 2x is just 1 over 2x times x. So the x's cancel, so it looks like your final answer is just x's are gone, so 1 over 2 natural log of 2x. Remember to bring that 2 in front and don't multiply it by the 2x. Okay, so that's D. Let's go on to E. So huge thing. Since this is not natural log, remember what we have to do. Taking the derivative, you're going to first say 1 over, change it to natural log, and then put the 2 behind it. So that's the beginning. Then do it like you would normally if it was natural log. So then it's times 1 over whatever was behind the term times the derivative of that. So that's going to be 3x squared. So just cleaning it up, I would probably do the following. Let me back up a little bit. I would put 3x squared in my numerator, and my denominator, I would put the x cubed plus 1 in parentheses in the front times the natural log of 2. And that's your best form of that answer. So that's E. So let's go on to F. Okay, so for this one, f prime of x, it is natural log, so it's going to be 1 over the x cubed plus 1 to the 1/2 power, and then x9 minus 2. Now, you've got to take the derivative of that next. That's going to be a product. So let's get our product rule going. Just make this a little bit shorter. Okay, so I'm going to put a big old box. And we're going to say left. So x cubed plus 1 to the 1/2. D right, which is just 9x to the 8th, plus right, which is going to be, I'm just going to write it down here, which is going to be x9 minus 2, d left, which is going to be 1/2 x cubed plus 1 to the negative 1/2 times the chain rule, which is going to be times 3x squared. Okay, so let's have that look a little bit better. So f prime of x equals 1 over, may I just call this little thing box? So this is going to be box. Okay, so 1 over that box times, I would bring the 9x to the 8th in front. Then you have x cubed plus 1 to the 1/2. And then I have plus, I would probably put the 3 over, or 3x squared over 2 right there. I would probably bring the x cubed plus 1 and put it under a radical in the denominator, and then I would have that times, using parens, x9 minus 2. Okay, so that's the best form of that. All right, so let's go on to our next problem, which is G. Okay, so this is kind of a tricky problem. You just have to do it carefully. Okay, I always say the first thing you're going to do is take that cotan of 4x and put that squared way outside. Okay, the reason why I do that is I want to remind myself I'm going to do the power rule first and then the chain rule. So now that I've rewritten it, and I'm going to erase this because I have not taken the derivative yet. I've just rewritten it. So now let's take the derivative. So power rule comes first, 2. Don't touch anything in the parentheses. Raise it to the 1. Now take the derivative of cotan 4x. So let's remember that the derivative of cotan is negative cosecant squared x. So that derivative is going to be a negative cosecant, use the same exact angle, 4x, and that's squared, and then times the derivative of the angle, which is 4. Okay, so my final answer is the following. So f prime of x, first off you have the 2, so let's make that negative, right, because you've got a negative cosecant, and you have 4 in the back. So negative 8, and then I'm going to have cotan 4x, and then times cosecant squared 4x, and that's not bad. Okay, so key things. Whatever angle you started off with, which was 4x, you have to have that coming back. If you have a power in your trig function, you should assume, or you should always expect, you're going to get 2 trig functions in your answer. All right, so those are the big takeaways from this problem.